development, so we want to make sure. So the first thing that we did, we talked about the fundamental counting principle. The fundamental counting principle. How many 3-digit numbers do I need? Can I make? No restrictions here. How many 3-digit numbers can I make from the digits 1 to 5? You put down blanks for the number of decisions that you got to make, and then the number of choices go in the top of the blanks. So, like that. So that's where we began. Okay. The second thing that we looked at was factorial notation. So what is factorial notation? So 4 factorials, 4 by 3 by 2 by 1. Okay, 24 ways. N factorial is n minus 1, n minus 2, all the way down to 1. Okay, so that's factorial notation. So that was 4.2. 4.3 was working with permutations. So back to the first example that I showed you. Okay, this is n factorial over n minus r factorial. Alright, now this is where we're going to start with today, so we have to make sure that we remember what we recall what we're doing. Okay, so I want to choose from 5 digits. I need 3 of them. So my n is 5 factorial because that's the number that I want to work with. I then subtract 5 minus 3, which gives me 2 factorial. So I have 5 factorial over 2 factorial, which is the same as 5 by 4 by 3, which gave me 60, which is what I had before. Okay, so that's your permutations. All right, so far? Okay, so we briefly talked about 4.4. So let's have a quick look at that today, or a little bit longer look at that than what we've been doing. Yeah, sure thing. Okay, so permutations when objects are identical. So I touched on this using seam. How many ways can we spell or arrange the letters in the word seam? Again, 4 factorial for that guy. But what about when I rewrite the word in which I have common letters now? Yes. Okay, so you take all of the letters in the word and you divide by the number of ways in which the ones that are identical can be arranged. So there's 2 identical ones, so I have to divide by that. So in every case, in every circumstance, you take the number of objects and divide by the number of like objects. Because basically what you're doing is if I look at E and A, how many ways can I arrange E and A? Well, if I have 2 blanks, E or A can go in here, so I have a choice of 2 and a choice of 1, right? Which is 2 factorial. So I have to divide that out because I've got 2 of the same thing. The E and E look the same way whether I put it here or flip them. Okay? So that's that. This next part right here is the one that I want to do it in applied, and there's a way in which we do it in pre-calculus, and I don't care which way you use it, but it is a little bit more difficult to understand. So those of you that are half asleep right now need to follow what I'm about to do next. Ricardo jumps into a taxi to travel 8 blocks west and 3 blocks north across town. Assuming there are no one-way streets, how many routes could the taxi driver take? Now, in pre-calculus, so this is on page 101. In pre-calculus, we simply take the number of blocks and divide it by the number of similar turns that we have. So in this case, we have to go 8 blocks north and 3 blocks to the, was it east? West, sorry. Oh, 8 blocks west and 3 blocks north. Okay, so this is the way we would do it. Now, this works great if you're going from point A to point B and there's no different pattern, which I'll show you in a minute. However, there is another way in which we have to do this. So I need 1, 2, 3, 4, 5, 6, 7, 8. So do this. Sorry, first time trying this. 3, this. 1, 2, 3, 5. Alright, I'm making a mess of this. Try this again. Okay. Okay, so I need you to follow very closely as to how this works. I'm starting down here. This is my starting point. This is my finishing point. Now again, this is the applied way of doing this question, which seems like a lot more work, and it is, but it's also necessary to figure this out because they're going to change it on you and they'll add something in like this down here. And so you've got to know how to do it. And you can't use this method when you've got an addition down here. So for right now, we want to figure out how to do this. So ask questions if you have any concerns. All right, so the first thing I do is I draw diagonals. So I draw a diagonal here. All right? How many ways are there to go from here to here?
2. Oh, no, just 1.
Just one way. And from here to here is 1 as well. Right? So now if I draw a diagonal again, like that, there's still only one way to get there, right? As long as I'm only going left turns and up. Okay? So I can't go, you're going in one direction only. So then there's only one way to get there as well. Going straight across. We all agree?
Yeah.
Okay. This guy right here, how many ways are there to get to that point? From there to there. There's 2 ways in which to do that. So what I do here,
How is there 2 ways?
I can go up and left or left and up. Right? So what I do for this guy, I add these 2 together and that goes right there. Okay? So far so good. So now I'm going to do this one. Up like that. Again, there's only one way to get there, and there's only one way to get here. So that's the easy part. Okay. So now, how many ways to get to this point right here? Okay. Take this and add it to that. So there are 3 ways to get there. Okay. Just the same as there are 3 ways to get here. We following this? Like I said, this looks complicated, but it really isn't. So now my next goes like that, still 1 here, okay? So how many ways to get to here? 4. How many ways to get to here?
Oh, 3.
6. And up here? 4. Again, I'm just adding the 2 numbers that are in the diagonal before it to get to that point. Okay? Do it again. Okay, so it's 1 again here. Alright? To get to here is how many? How many? 5. To get right there is 10. And then, what is it here?
10.
10 again. Remember, just adding the diagonals. One here. How much right here? 6. How much here? 15. And here? 20. Anybody not following this process? You're gonna find out what the point is when you get to the end. Okay, so 1 here, 7, 21, 50 and 20 make 35. Okay, up here now, 1 again to here, this is 8, 28, and 56, 21 and 35. Okay, so let's keep going. 1 and 8 make 9. 8 and 28 make 36. 28 and 56 make 84. Diagonal right here. 9 and 36 make 45, right? 36 and 84 make, what is it? 120. And then finally right here is 165.
So that should be how many possible.
So that's how many possible routes there are to get to that point. Okay? Now, like I said, the easier way to do this question is this. And punch it in and you would get 165. However, if I add on or I have an excess, so if I put this down here, this method doesn't work so well. So we have to figure out how to make that happen. Okay? So you're going to see that on page 102, question 5A and 5B. How you can't use this method right here of factorials. Alright? So all I do is I just draw the diagonal across, everything across, all the lefts and all the ups are all 1s, right? And then you're just adding the diagonals to get to the next spot. Okay, so there would be 165 ways to go 11 blocks, in which you go 8 blocks to the west and 3 blocks to the north. Okay? That's the only thing that's complicated in this 4.4. And you're 99% going to see that on an exam, on the provincial exam for sure. They will show you a question like this on the exam. Everyone has had one. So you do need to know how to figure this out. Yes, Kelsey?
For the addition, we will do the
Yeah. The diagonal works better. So like what would happen here is I go like this. So it's still 1 and 1 here, right? 2 to there. Go like this. So this is 1. This would be 3 here. And then still 1 here. 3 here. So it'd be 6 ways to get there to that point. And then all of these would be 6s. And then so your math would start with, instead of these being 1s, they'd be 6s because there's 6 ways to get to that now. Once you get to that point. Okay? It is it does get kind of complicated, like in a couple of them. Okay, so that's 4, 4. So I'm going to show you combinations today. Exploring combinations. All right, now, what's the easiest way to do this? Fortunately for you, you don't have a choice. Okay, so NCR. Again, under math and probability on your calculator, you can find the NCR button. NCR works very similar to permutations with one wrinkle. The difference between a combination and a permutation. In a permutation, order is important. We have stressed this. We did this last week. You have to have order. So if I'm selecting 5 people, and then I got to arrange them in order, that's a permutation. If I'm selecting 5 people from this class, and I don't care about the order, that's a combination. So a combination then, you select, and then you divide by the number of ways in which you can order those people. So I'm going to show you how this works. All right? You have, let's say we have 20 students in this class, and I need to select 3 of you. But I need a president, a vice president, and a treasurer out of this class. Okay? That means that I'm expecting order. I want to pick 3, and then I'm going to order them as president, vice president, and treasurer. So that's a permutation. So I go 20p3. So that's 20 factorial over 17 factorial. Agreed? So then I have 20 times 19 times 18. Okay? Right?
Yeah.
What is that?
6,840.
Okay, 6,840. Okay, so we're at 6,840 here, right? So that's the number of ways I can select 3 of you and then put you in as president, vice president, and treasurer. Okay, because what I'm doing is I'm taking into account that there are 3 factorial ways in which I can arrange those 3 people once they're selected. So if the question says, all right, out of the 20, I only need 3 of you to go sit out in the hallway. Okay? So I only need to select 3 of you. There's no order involved here. So then I take this number and I divide it by the ways in which I can order those people, which is 3 factorial. All right? So a combination works like this. 20C3 equals 20 factorial, 17 factorial, 3 factorial. So 6,840 divided by 6, which is
1140.
1140. So if order is not important in the question, you use a combination for it. If they specify that there has to be some sort of order, you need the first, the second, or the third place person. You need a president, vice president, treasurer. They'll specify. Then you use a permutation. If they don't, then it's just a simple combination. Now I showed you the other day, what were the chances of winning the Lotto 649 if you had no order? It was like 1 in 14 million, 13 million something, right? But then if you needed all 6 of those numbers in the exact order they were picked, you'd have a 1 in 1 billion chance of winning the Lotto. Okay? Take a look at page 104. All the diamonds from a standard deck of playing cards are shuffled, and 4 of these 13 cards are dealt in a row. How many different permutations of 4 diamonds could be dealt? Okay, so I have 13 diamonds. It specifically says permutation. So I have 13P4. So they want the order in which it happens. So what's 13P4? Well, that's 13 factorial over 9 factorial, which is 13 times 12 times 11 times 10, right? Okay, which is 17,160. Okay, so far? Suppose the order does not matter. How many different combinations could be dealt? So now, I just need to select any 4 in a random order. No order needed. So now I'm using a combination. So what am I dividing by?
13 and 2, add 4,
No, what am I dividing by?
4,
4 factorial, right? Because that's the number of ways in which I can order the 4 cards. So a combination is 13 factorial, 9 factorial, 4 factorial. Again, you can punch that into your calculator. 13, math, probability, NCR, 4, done. I'm just showing you the mental math way of doing this. Yeah, we're still using a calculator to get 17,160. Okay? That's that. Now, let's look at 106. And I got to show you all of this. You're going to have all week to work on this. There are 2 ways in which they write this out. Okay? They'll write it as NCR, or they'll write it with N over R like this. That means combination. That's just a different notation that they want you to know. That's what combination means. Okay. Here's the type of question that you're going to get as a combination question on an exam. This is the guy that you need to know. This is the one that you do in your grade 12 pre-calculus when you're using probability. This is the guy. We have to know how to do this question. So we're going to look at it, we're going to study it, and then we're going to, this is the be-all, end-all type question. Look at example 2. At Karina's birthday party, there are 7 boys and 9 girls. Karina has to choose 6 children to start off a party game, including at least 1 boy and at least 1 girl. In how many ways can she do this? Okay. So she needs 6, right? And she needs at least 1 girl and 1 boy. So the first thing I'm going to do is write out all of the possible scenarios. Okay, for the 6 people. All right? So, girls, boys. So let's say I have 1 girl. How many boys am I selecting? 5. Okay? 2 girls, 4 boys. 3 girls, 3 boys. 4 girls, 2 boys. 5 girls, 1 boy. Those are all my possible situations, right? Scenarios, right? We all agree?
Yeah.
Okay. So I'm going to do this 2 ways to show you, because there are 2 ways to do this question. So the first way to do this question then is my scenario number 1 I'm going to write out. So I'm choosing 1 girl from how many? 7 or 9, which is it? 9. And then I'm choosing 5 boys from how many? 7. So that works out like this. 9C1 times 7C5 equals. Okay, so far? Scenario number 2, I need 2 girls from the 9 and 4 boys from the 7. So I go 9C2, 7C4. 9C3, 7C3, 9C4, 7C2, 9C5, 7C1. So far, so good?
Mhm.
So now I use my calculator and I gotta solve in each of these cases. So I'm multiplying across, just like I did with the tree branches, right? You multiply across and then you add the cases together, the scenarios together. Okay? So in this question, I'm gonna do the quick math here. 7,917 ways in which to do this. So there's all you have to do for that. All I'm asking is I can happen here. And 7,917 ways. So far, so good? Yes or no? We okay?
Mhm.
So this is the main way in which you can do this, but there is a shorter, quicker way to do it, but you have to understand this first before you can do that. So are we okay?
Mhm.
All right. I'm going to show you the shorter, quicker way of doing this. First of all, if I ask you just to select 6, gender aside, how do I select 6 in this case? So I'm using a combination. How do I select 6? How many people are there total at this birthday party?
16.
16? Say that again, Jake.
16.
Not 9. No, I only need 6 people.
Oh, 6, sorry.
Right. So you got it right. Okay, does everybody understand it?
Yeah.
So the total ways in which I can pick 6 people at this birthday party is 16C6. Agreed?
Yeah.
Alright, so that's the total possible way I can pick 6 people from 16 if I ignore the gender. Okay? Now, here's the thing. I wrote all the scenarios that were possible right there, right? Well, there's 2 scenarios that aren't on there. What are they? 0 and 6 and 6 and 0. We all agree?
Yeah, we got the one each.
So if I find out how many ways I can pick in which those 2 other ones don't occur and subtract it from my total,
Mhm.
I'll get every other one. Agreed?
Mhm.
The thing about at least, they use this word a lot. You can then take away the chances that it doesn't happen from the total ways of doing it and get to the same solution. So I'm going to go 16C6, subtract 9C0, 7C6. So that's it, there's 0 girls, right? And 6 boys. And then I'm going to go 9C6, 7C0. Okay? So 16C6 is 8,008. What is 9C0? Say again? What is 9C0? No, don't use your calculator. How come? Nope. I said 0 factorial is 1. But she's right. The answer is 1. How many ways can I pick no girls? There's only one way to do that, right? So 9C0 is 1. Okay? Now 7C6 works out to 7. Again, what's 7C0? 1. 9C6 is 84. And when I subtract them, I'm going to get 7,917 ways in which to do this. The easiest way to do the question when it says at least is find out your total number of ways that you can do something and subtract the ways that it doesn't happen. So when you get to that point this week, that's the easiest way to do this question. It's not easier than the other one, it's less work. We're all about less work in this class. So there is less work on the right board than there is the left. But the left is just as easy as the right. Just more work, more calculator work. Okay? Alright. I'm just gonna shut the camera off now. And then I'm gonna take some questions, if you have any, from, alright, are there questions that, Sam?
This is page 95.
95?
Oh, I feel like these are so simple, but I keep messing them up.
Where are you at, Sam?
Number 3.
N plus 1 factorial
Yeah.
over n factorial, they are pretty simple.
Okay, but so wouldn't it be n factorial add 1 factorial once you put it to the brackets?
Absolutely not, you never throw that factorial through the brackets, ever. It's not multiplying, it's a function. It's just like if you have, the sine of 30 plus 45. You don't put the sine through the brackets.
Oh, I see.
You don't do it, because it's a function. So we don't do that. It's not multiplying by the factorial. So you expand the factorial. So which is larger, n plus 1 factorial or n factorial?
N factorial.
Is larger than n plus 1 factorial?
Oh, no, n plus 1 factorial.
Okay, so then I'm gonna take it down. So n plus 1, what's the next number smaller than n plus 1?
N plus 2. Oh, just n.
There's your answer. What about what's right? Okay. Let me do B a different way. What does that equal? No? Okay, try this again. No, I don't want the number. What if I have this?
Oh, 5 factorial.
So then what is that? Done. So then what's your answer?
N factorial.
Done. Yes. Do you with that? Makes sense?
No. You just said B?
Well, sort of. I showed her how to get to B. I didn't do it.
Oh, so like, it just said,
Like basically, what is that saying?
oh.
You're taking the number times the next number times the next number smaller than it factorial. Well, that's the same as 9 times 8 times 7 factorial, right?
Right.
So that's the same as 9 factorial.
You just expanded it.
Yes. Okay. Others? Yeah, Kira.
Question 5 on 98.
State the values for which n, which expression is defined. State the values of n. So I've got n factorial, so that, which is larger, n factorial or n minus 2 factorial?
N factorial.
Okay, so let's expand it then. So I go n times n minus 1, right? Times n minus 2 factorial over n minus 2 factorial. Do you agree with me?
Yeah.
I can't. Right?
Yeah.
State the values of n for which each expression is defined where n is an element of the integers. So in this case, n would have to be greater than 0, correct? So it's 2? Oh yeah. Sorry, my bad. So how do I do this? What's the easier way to do this? At a loss at the moment, so n would have to be greater than or equal to. Okay, so the smallest possible n value that you could have would be 2, right? Because, or I guess it could be 1. Could be theoretically, could be 1. You can have 1 factorial, right? But you can't have 0, but we only go to 1. Correct? So then, for this, well, I'm not sure how to approach this. Oh my God. So, is the answer in B3 then?
These must be ones, as C is negative 2.
B is 1?
Wait. The most not like
Oh. Well, it could be. N is 1. No, it can't be. N would have to be 2 again.
Is this 4.4? Oh, it is 1.
It's 1?
Yeah.
So I'd have 2, 1, and 0 factorial. It's 2. It's gotta be 2. Yeah, 5B. So 5A is what?
5A is 2.
2. And 5B should be what?
1.
This question is the first one.
Okay, well, let's just leave that for now. I'm gonna have to figure that out. I'm not sure the correct process for it. Okay,
Well, it might be like, it says right beside like 0 factorial is defined to be 1. Maybe they're saying, like integers, that includes 0, right? So
yeah,
the lowest possible value is 0.
yes.
So on the bottom of A, 2 minus 2 is 0, and so that's the lowest.
Yeah, see, I get that, yeah. And so I would get that I agree for A.
Yeah.
That's the way I would look at it, but I can't use that because there's no denominator in B. So I can't use that as my guide for that. But then that doesn't also satisfy, if I put 2 in here, that's 2 and then 1, right? But if I put 1 in here, then I'm gonna get 2, 1, 0. If my n's 1. And so that doesn't have the same balance.
Yeah.
So I'm not sure. We'll leave that for right now. Okay? I don't know why, I don't remember this question either. Okay, anything else today? Lex?
For 4A, when you're writing it with that presentation thing, the only way that I could get 20 as an answer if I did 5P2, but I don't know why I did that.
How many ways can Adam, Benoit, Carrie, Philip, and Eva be appointed to a student committee with 5 different positions under each set of conditions? No. Carrie's to be president, so you're setting him in place, so he's 1P1. Okay? So, that's 1. He's held in place. What's the answer for it? 20? So then, the answer should be 24.
It's 5
4P, it should be 4 factorial. Yeah, I think the correct answer is 24. No, 4P4. You've already picked one guy, so now you're selecting 4 from 4 and ordering them. So I think it should be 4P4, which is 4 factorial over 0 factorial, which is 24. Okay, so I think the answer is 24 for that. Okay,
So then if neither, whatever is at that, will be president, doesn't 3P3?
I got 5 P three.
Oh, because there's still 5 people?
yeah, but you've gotta choose 1 from 3 first to be president. So you have to choose 3P1. And then once you've chosen the president, now you're going 4P4.
So what does the 3 represent in front of the P on that one?
And choosing from the other 3 people to be president,
Oh,
right?
and there's one president slot, yeah.
So out of those 3 remaining people, you're choosing the president, and then after that, you're choosing any of the 4 to be other board members.
But you get 72 if you do that, and then that's just a 60.
Yeah, I'm okay with 72. I think that's right.
Why couldn't it just be 5 P three? Why couldn't it just be 5 P three? Because you're just choosing from 3 positions for 5.
No, you're not.
I'm choosing, the 5 positions.
No, you're not. You got 5 people, you gotta choose all 5, but you're choosing a president for 1. The president's the only guy that we know of. So there's 1 person that's president, and that's it. Okay? Alright, so my expectations then for this week is we will be, you should be done to the end of 4 or 5 for Thursday. When I get back Thursday.
You're not here tomorrow?
When I get here tomorrow or Wednesday. So you have to have this completed to the end of 4 or 5 for Thursday. And 4 or 6, if you happen to get done, 4 or 5 short. Only 5 questions on it. So if you get to that point, then do 4 or 6. Okay? So our testing date will be sometime next week. But we've got lots. I'm not gonna rush through this one. This one I wanna make sure that we've got a good grasp of. Okay? Yeah, Jake.
I'm just wondering, because I see marks on Power School, the test getting handed out today.
I think I've had a few of them out, just didn't hand them out to everybody. Everybody was here. What do you want?
I have no question.
Well, you can ask me after. Okay, everybody else is okay today? Okay, you've got lots to do. You got a busy couple days here. I don't know who's in, so you're probably on your own. Help each other out.
Did I get some message from the office? So
No.
Get it again today?
No.
I'm
Heading out right by